Just getting people in from the waiting room, so I'll give it another minute or so. Okay, no one new, so we'll go ahead and get started. Hello, good morning. Everyone can hear me okay? Good, great. Okay, we've got another FRQ coming at us this morning. It's technically a long FRQ. I suspect that you will find that it's definitely not going to take you 25 minutes. And we're a small group this morning. So, you know, I'll just kind of check in with you once I set you free on it, to see how much time you need, because I don't want to like just make you sit around and wait to ask questions if you have them. I personally think the good thing about, so what I've seen, so, okay, rewind. Full disclosure, I haven't taken the AP Bio exam for at least 22 years. Yikes! So me personally on an AP Bio exam, like my experience is dated. However, I've taken many standardized tests since then and beyond, and the way they word questions and stuff, you kind of get used to them. This is the same as how like the GRE is, the MCAT is like this, NCLEX, all these different like, you know, higher education platform type standardized testing, they all look the same. My point being that I've read a lot of these questions, and now having read these new AP Bio questions, like you start to see the theme of what's, you know, what they constantly are doing over and over again in certain types of questions. So what I've noticed in the last week and from my previous experience is that these short FRQs, while they are like kind of, you know, they're meant to have quick answers, they're also trying to be trickier. Like they want you to kind of dig for what they're really asking, so that they kind of test how you're reading the question. And then the long ones are super straightforward, but they just might take you a little bit to complete, if that makes sense. They're not tricky, they're very straightforward. They're like, here, you need to answer this, 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 and this, but it's just kind of a lot. So it's short but tricky, and long but super straightforward. That's what I've noticed. Anyway, so today we're gonna do a long FRQ from Unit 2. And I'm gonna put it up on the screen in a second, and we're going to just kind of, give you a second to copy it down. And then we'll pick apart what it's actually asking first before we jump in. And then I'll let you go to town on it. My guess is you'll probably be done in 10 minutes or so, maybe 15. And then we'll discuss if you want, ask questions, or again, you can just send them my way. For those of you that sent me your FRQs from yesterday morning to check out, I'm sorry I haven't gotten to those yet. Wednesdays are crazy Zoom days. I Zoom all the way until 2:30, and then I'm kind of fried. So I'm sorry I didn't get to those. I will get to all of them this morning, and if you send me today's, I'll get to those today as well. Oh, Xander, what happened? You fell out. back in. Oh, hooray. Leander, you fell out. Are you okay, buddy? Everybody's internet's being so like spotty the last couple days. I feel like, don't you feel like kind of like maybe like these provider companies are like starting to take advantage? Like, oh, does your internet seem slow? Yeah, who's in charge of that? Maybe you should have an upgrade. Okay, I mean, I just feel like I'm just being a little cynical, but anyway. Okay, let's get this FRQ up. You guys can copy it down. Again, just stay organized with where you're keeping all of your FRQ practices. Like, make sure they all have like a little unit 1 or whatever, so that you are staying organized. Can you see that okay? I know it's kind of tiny. So I'll read it out loud too. The initial couple sentences are like the details you need to know, and then the actual question is underneath the table. So it says, water potential in potato cells was determined in the following manner. Okay, so basically they're telling us, they're going to tell us a story. The initial masses of 6 groups of potato cores were measured. The potato cores were placed in sucrose solutions of various molarities. The masses of the cores were then again measured after 24 hours. Percent changes in the masses were calculated. The results are shown below. Gives you a table, gives you all the different molarities of the sucrose solution, and then it gives you all the different mass percent changes of the potato cores. Then it says, graph these data on the axes provided. From your graph, find the apparent molar concentration, the osmolarity, of the potato core cells. Okay, I'll give you a couple minutes just to jot it down, and then we're going to pick it apart. Try really hard not to start yet. I know it's tempting. Try really hard not to start yet. Let's pick it apart first. All right, probably pretty close to copying this one down. You can always go back. I'll throw it back up once we are done picking it apart. Let's see. So I'm going to now share a little whiteboard action. Okay. I'm going to charge up my pen today so I don't have to have it plugged in. Hooray. Changing up the color today. Teal? It's too hard to see. How about purple again? Okay, so it talks about, I should have had it up for myself so that I could see. I wrote it down and then I just picked it up. At first it tells us, hey, I'm going to tell you a story, right? It's not going to beat around the bush. It's just going to tell us all the facts that we need to know for this FRQ. Stand by. Okay, so it's going to tell us all about an experiment. So for me personally, I'm a visual learner slash, just how I go about, deconstructing a problem. I really need to see it visually. What does this experiment look like? If you're in my biomed class, you know this, but like I make people draw pictures of experiments all the time because I just really feel like it helps visualize. So for me, I personally would, on my scratch piece of paper or on my response, start to draw a picture of this experiment to just help me visualize it. You do not have to do that. Maybe you're good at just like putting this in your mind's eye and you can picture it on your own. Maybe you're like, I don't need to picture it, I just need to know the numbers to move forward. But I'm just telling you some hints, some tips if maybe you get stuck trying to visualize some of these longer word problems. So it talks about how they're going to have a group of 6 potatoes, and they're going to take their mass, and then they're going to put them in different molarities of sucrose, ranging, and I looked at the table, somewhere between 0 and 1 molar, and that's going to be for 24 hours. And then they'll take them out, they'll take their mass again, now that they are all drippy with the sucrose or not, and see over time what was the change in the mass. Expecting that, okay, we're going to drop this spongy like vegetable into some sugar water, the mass is probably going to increase. Maybe that's what they thought during the experiment, whatever. And then they made a table of it, right? And the table is really, the table's really clear for us, right? It's got 2 columns, perfect. I'm supposed to make a graph out of this, great, I can assume one is my X and one is my Y. Then it gets to the actual instructions. And here's where we want to kind of pick things apart. It says, graph these data on the axes provided. Graph. That's an AP term. Seems like, oh, that's a term you'd use in lots of classes. But as far as graph goes for the AP, here are the things they want you to do. Doesn't say all the things, all it says is graph. You are expected to know what they mean when they say graph. When they say graph, they want you to put all of the data on the graph as points. So you're not going to leave any out. You can't just be like, oh, I can tell by looking at this that it's going to slide down in a curve. Okay, that's nice, but you need to put every single number that they express on this graph. If they wrote it, you need to put it on the graph. They also don't tell you, but they want the axes labeled. They want to see that you know what a graph should include. And not for nothing, you should label them exactly like they're labeled in the chart. And whether or not they included it, if you know the units that things were measured, include those units. That could also mean the abbreviation. Depends on what they used in their chart. In this particular chart, it's labeled, the x-axis is labeled molarity of sucrose in beaker. And then they show you that the very first unit is a capital M, and that's for molar, but the abbreviation is big M, right? So you want to put that on your graph as well. And then you also want to include very clear increments on your graph. On the graph, little piece of graph paper that they give you, obviously it's already laid out like graph paper, so you don't have to worry about, creating a, perfectly scaled distance between your increments. It's doing that for you, but just make sure that whatever you decide, those each line represents, that you're very clear about what they represent. And last but not least, of course, every good graph has a title. And the title of your graph should always kind of sound like the title of an experiment, where we include both the dependent and independent variables. Oops. Okay, the last thing I want to say about this FRQ before I turn you loose on it is that it kind of mimics the one we did yesterday in our class Zoom, in the sense that it probably feels like, well, this is kind of a one-word answer, because what are they looking for actually? From your graph, find the apparent molar concentration of the potato core cells. Okay, so that means I'm going to somehow use my graph in the end to pinpoint one particular molar concentration that I think is the concentration of cells. And I'll let you, kind of stumble through how we do that, and when you're looking at your graph once you're done with it. But literally, it's asking for a molar concentration. To me, that seems like it's just going to be some number, right? Oh, it's going to be whatever, 0.78 molar, period. When it seems like it should be just a one-word answer, that's where things can get a little tricky, right? That's where you need to answer in the most absurdly complete sentence. And then, not for nothing, I think it's always good, this is a good indicator too, that maybe you should be drawing a picture. Well, it works out because we're also supposed to draw a graph. So we kind of already have the visual representation. So just consider somehow relating your answer, that really super complete sentence, back to your graph with some kind of arrow or circle or indicator that's clearly labeled on your graph. Okay, so again, here we are. It's a long FRQ. Technically, you have 25 minutes. You would never go through all this preparation getting ready to solve a problem, because that's why we're doing it now, because now you know how to do it fast. Or now we're learning how to do it faster when you're in the real thing. But that only took us 10 minutes to get ready. And now you probably feel like you have a better story to tell on your graph and you can whip it out pretty fast. Okay, so normally I would say 25 minutes for this, but because it's a small group and I'm sure this helped kind of get us going, I'd say max 20, but I'll check in with you in about 10 and see how you're doing. Does that sound good? All right, I'm going to put the FRQ back up in just a second. Oh, I'm not going to change my whiteboard quite yet in case you're still using that. And then I'll go back to the FRQ. Ooh, one thing, guys. I'm just trying to think of things that maybe you would do, but I don't think you would do this. But, obviously we have tons of apps and resources within our iPads and computers that will graph for us. And it being open note, obviously you would have access to be doing that. Here's why I suggest not doing that, because you cannot then paste a copy of whatever graph you make in Numbers or Google Sheets or whatever. You can't paste that into this answer. because it very clearly says to use the axes provided. So the last thing you want to do is take a graph that you made and try to paste it over this, if that makes sense. If you got a question like this, you would definitely need to do the graph on the graph paper they give you. Okay. That's not to say that if you want to like throw these numbers into a graph quickly during your time just to check to make sure it's right, that's totally fine. That would be totally allowed. And then copying that graph onto their graph paper, totally fine. However, it's really important that if they say use something that they've provided, you need to use what they've provided. So obviously today, a little bit harder if you're just using the picture or you're just using scratch paper, totally fine, doesn't matter at all. It can be messy today, but just so you know. Oh, no, baby. Okay, we're just creeping up on 10 minutes. How we doing? Do you need more time? Totally fine. Sadie, you're good? What, 2 more minutes? Franklin, how about you? 10? Okay. Xander? You're done? So, for some reason, I can't hear you for some reason. You're good. You're good. Okay. Moira, you good?
Yeah, I'm good.
Okay. Jayla, how about you?
About like 5 more minutes.
Sure. Yeah. Sounds good. Perfect. Okay, let's go ahead and just have a little chat. I'll just like start off by seeing if anyone would like to disclose their approximate cellular osmolarity that they came up with. Sadie?
I put 0.3.
Thumbs up, anyone else, or a shout
I
out?
also put 0.3.
Great. Jayla, anyone else get something close to that?
Yeah, I just put 2 or like 0.27.
Okay, 0.27. Xander, what'd you get? 0.29. Moira? Somewhere in that ballpark?
I got 0.3.
Great. So that's good, right? To me, that says we don't have to work backwards too much for me to know that your graphs probably all look the same, which is great. That means we're all in good shape as far as making the graph and then relating the graph to where you would be if your cell had that equilibrium state. So what that balance is for the internal chemistry of the cell. So that's all good news. So do you have any questions beyond that as far as what your answers should look like or how to go about doing this? We did the whole thing, even my long spiel about how to read this, in 25 minutes. So you can see why you don't have to use all that time, like you guys got through that in 12, 13 minutes, no problem, and have all perfect answers, I'm sure, and are ready to submit. Don't overthink it. Don't try to put bells and whistles on it. Like it's probably good just how it is. Trust yourself, upload. So yeah, questions for me?
Do you think they would probably give us a graphing question, or would it? They would?
I do. I think, well, here's the thing. I know for a fact they are in the mix,
Okay.
but will you, Sadie, specifically get that one? Who knows? But graphing, creating tables, interpreting graphs, for sure you'll get in your long
Okay.
FRQ. Yeah.
Because stats was like not doing a lot of math stuff, so I thought maybe they wouldn't want to, I don't know.
Gotcha. Yeah. It's fair game. What we didn't cover a ton in our last unit that you could see in some of these long FRQs in terms of like interpreting data, and we're going to go over this when we circle back all the way down to unit 6 or whatever the last one is like statistical analysis, meaning like when you see a graph that has, standard deviation or error bars and what those mean. We did, a couple short little activities on it when we were back in school, but we didn't really like dig that home, and that's something you could see. So I want to make sure that we circle back to that.
Okay, cool.
Cool. More questions? Yeah, Xander.
Sorry, this is a little off topic, but I hope you can answer. For the homework on the notes on the videos, are the notes supposed to be solely on the videos, or should they be combined with like notes from past and stuff?
They can be any combination of what you're doing to study, just categorized by unit, if that makes sense. So at the very least, you should have some notes that you took from the video, specifically maybe the FRQ that she walks you through on the YouTube channel. And then in addition to that, maybe you went back and looked at your old notes and jotted some things down that were still a point of confusion. Maybe you looked at another website or resource or Fiveable and jotted down some notes from that. Maybe within your Unit 1 notes, you have all the FRQs that we did together in the morning and during our Zoom. So yeah, it can be any combination of whatever it is you're working on for Unit 1, and then same thing for Unit 2. One thing I'd love to ask if anyone wants to share is what you titled your graph. Anyone want to share what they picked for a title? And did you remember to put a title on your graph? Right, is it wrong if you don't put it? No. Is it a 5 if you don't put it? No. So if you want, that's how you get to that 5 level. They got to really be like, whoa, look at that shiny graph, totally labeled, super clear. all of the units. I get it. That is the most clear graph, and I see exactly the point on the graph where they got their 0.3 molarity. They highlighted it, they started, they put an arrow or circled it or whatever. It's super, super, super clear. Anyone want to share their title? I'll share my title. How's that? And then maybe you can just compare and see if yours was close to it. For my title, I put the effect of sucrose solution concentration on potato mass. That's just kind of, I got the potato mass on there. You could have said something about the increase in the percentage of the potato mass. But as long as you are somehow comparing your independent to your dependent variable, or the effects of the independent variable on the dependent variable, that's what makes a good title. What you don't want to title your graph is potato graph, right? Or like graph of sucrose. That's not what that is, right? So just make sure that if you choose to do a title too, that's the other thing, it's a double-edged sword, right? If you remembered to do the title, you're like, oh yeah, Miss Masonette said I should definitely write a title. Potatoes. Oh, that's actually gonna hurt you more than it's gonna help you, right? So yeah, you remembered to do a graph, but it's not really a title for the graph, right? So just something to think about. Again, if you literally, all you did was draw a curve on their graph paper that they gave you, maybe threw some dots on it, maybe you like wrote an M on the x-axis and the percent sign on the y-axis, and you wrote next to it 0.3 molar. It's a 2 or a 3. It's probably a 2. They see that you kind of did it, but you're not wrong. That's the problem. You're getting a 2 or a 3 on this question when you're not wrong. It's how right can you be, like the most right and the most clear. Again, you're trying to prove what you know.
I have a question.
Sure, Kayla.
So when you're explaining like what you got for your osmolarity, do you have to say like it's because the x-axis represents an isotonic solution?
Ooh, great question. Yeah, I kind of would. I would, in my answer, I would say something like, based on the intersection of my curve on the x-axis, which represents, as a 0 increase in mass percent, the osmolarity of a cell is approximately 0.3 molar, something like that. Does that kind of make sense? But that's a great point to show that the reason you picked it is because you know that particular point at the intersection of the x-axis is where it's 0%. Yeah, okay. Great point. Great point. Yeah, the more complete you can make that sentence, the better. Yeah, Franklin.
Can you just say that it can be determined where the graph crosses the x-axis, or do we need to be more specific?
So short answer is, yeah, that would be fine. Probably like 4-ish worthy, So like Jayla's saying what that x-axis represents is that bump into the 5 region. Again, not wrong at all. I'm looking for where my curve crosses the x-axis, which represents a 0% increase in the mass of the cell. Meaning nothing is moving in and nothing is moving out. I mean, you could go super crazy and draw so many pictures and like, oh, here's a picture of the cell and nothing's moving in, or it's an equal amount of in and out, blah, blah, blah. That's probably overkill. Because again, you don't want your reader to have to hunt for your answer. If you've got some paper that's got so many pictures on it and graphs and arrows, and then it's like, oh, they're going to be like, what? Where is it? You want to be able to sit back at the end, look at your paper or whatever it is that you answered on, and be like, oh, that's super clear. There it is. There's my answer, 0.3 molar in a nice complete sentence. Feeling good? Okay, pretty easy one. And that's it for the week as far as FRQs. You had 5 6 to go through. So we have 2 assigned in class, 1 in the Zoom session, and 3 over the course of the morning. So you had 6 to play around with this week. That's great. You should have all 6 of those organized somewhere. You know, maybe go back and highlight some of the key terms so that they're easy to find if you're trying to flip through them later. Alrighty. Okay, I think we're good. We're good for the week. We're mellow tomorrow afternoon-ish or over the weekend. What I'll do is pop up all the like basic answers for these FRQs so that you can at least go back and be like, okay, yeah, I got that right. But again, if you want more feedback, just send me your FRQ in an email and I'll give you direct feedback on what your answer was. Okie dokie, artichokes. Have a lovely day.
Thank you.
Bye.